Was our 22nd year as a team. We won last year the Midwest and the Greater Pittsburgh Regional, and we were first seed at the Wisco Regional, as well as getting engineering inspiration at Pittsburgh. And then presenting today, I'm Harrison. This is my third year on the team as a programmer.
I'm Caden. This is my third year on the team as a programmer.
We also have Steve here as a mentor in case we have any more advanced questions that we can't answer. Yep. So before we start getting into robot simulation, does anybody have a baseline definition of what that is?
Is a way to predict movements of the robot without having a physical robot do said movements.
Yeah.
Such as the positioning of the mechanisms or the position of the robot itself.
Yeah, exactly. There's many different programs that offer simulation, and they all specialize in like different sections of simulation. But in general, it's a way to test robot code without having a physical robot. The goal of simulation is just you can test code, ideas, paths, or mechanisms, anything. And now that we have a common definition, we can start getting into how it could help your team.
During the early build season, simulation can also be used while the robot is being used for drive practice or to test other parts. You can simulate or create autopaths quickly at home, in the stands, or while the robot is being worked on, or if you need a quick autopath. So if you have untested code, it won't damage the robot because you're doing it on a computer. You can easily identify issues within the code, whether that be mechanical or programming, and it saves a ton of time. Like if you're working like early build season and you just need to get out a couple quick auto paths, it's really easy to do. Simulation can't use values that come from the real world. Like an encoder might not be tuned, so the logic doesn't stop a motor correctly, and it could end up driving like an arm into the ground. Also, built-in simulation can't identify mechanical issues perfectly. Like something might be a programming issue that works in simulation, but not in real life.
Before we move on, does anybody have any questions about the benefits or detriments?
I heard you mention something about difficulties using a Spark Max for simulation, and you said something else, unless you use this other thing. Can you elaborate on that a little bit?
Yeah, so Spark Maxes, by default, they can't actually like fully simulate. I forget the exacts, but I don't think you can see like the output actually being applied with Spark Maxes. But there is something that you can do called a wrapper, which basically makes like pseudo class around SparkMax, and you can simulate speed in that case.
It overrides the method to simulate the speed is the wrapper's doing because it's not built in for the WPI line. So
Yeah.
it'll wrap around. There's other techniques they use also, but that's the one that we use.
Thank you.
Anybody else? Alright. So these two are the same. Last year we had an elevator and double jointed arm system on our 930 robot. That's what this is here. And there was also another green bar that would represent the elevator coming out. So it allowed us to like test out different positions of our arm before we actually put it on the robot. And then the Field 2D widget, it shows a representation of the field. It doesn't have any parts on it. Yeah, but it allows you to test out like how autopaths are working, driving in teleop. You can test out speed changes mid-match, and you can any other movement on the field that you would need to test out. And again, documentation is at docs.wpilib.org. We'll also go over a bit more of them once we get into the WPI Lib simulator.
Before you go on the field.
You can see the odometry again, and you can put in a CAD model of your robot into the 3D field. Does anybody have any other questions for AdvantageScope?
Go back to the line graph one. Your AdvantageScope.
AdvantageScope.
We found it useful to help show motors, speeds, or to do PID of the motors. So you can see the graph go up and see if it overshoots or not, or if it's jittering. It's a very good tool to help tune that. You can do that to live robot, connect to the live robot or simulation. So it's very useful for that. We also do it for the encoder when we see that the encoder wire is loose or something and it's jumping all over. You can see that. You can see because it shows the history of it, so you know if it's jumping. If you're looking at a number, you can't see if it's jumping back and forth, but a graph will show it.
Can you log the data from the match and then replay it?
Yes, you can.
Do you get into that?
We have another workshop going on.
Okay.
The debug. The debug. I can't speak.
That's later with
The debugging workshop will go over using AdvantageScope to log match files.
So if you tune the PID in the simulation, do you find that it's usually fairly accurate when you've taken over the actual real robot?
This is when we do it on the real robot. We connect the AdvantageScope to the real robot to get the real values, not through simulation. Because it's not helpful to the simulation. It's only as good as your emulation of the motors.
Okay, so Path Planner is a software that is created by Team 3015. On Path Planner, you can basically create your auto paths. When you can edit the robot's values, like the speed or the size of the robot. Every year, Auto puts in like the picture of the new field, so you know where you're going on the field. Yeah.
Sorry, I got it. I do it.
Okay. So this slide right here is basically bringing into the editor side of Path Planner. You have things called splines. Splines are basically like how you can control the arc or the shape of your line of where the robot's going to go. You have points, which are like different areas which the robot will like be present at, basically. Also, other points you have are stop points, which will stop when the event has completed. Speaking of, now you have events. Events are like we use Auto Command Manager, which uses different events, like when the manipulator will hold different kinds of game pieces, or telling the arm to pick up or drop off different pieces. So right now I'm gonna show you how to basically like what Path Planner is, how it works.
And we're actually also going to make a path. And you guys can tell us what path to make.
Yeah.
So here.
So you go to Add Path, the little waffle, and then Add Path.
This is the default path that it shows up with.
Yeah.
Obviously, this would not be a very good path.
Mm-hmm.
So where should we start with the path?
Does anyone want to give like a description of
Upside, mid.
what the path? Yeah, different things.
Can we go start at the bump?
Sure. So you would want to drag this green one, which is the starting one,
Yeah.
over to whatever your starting position would be. So let's say this
On the field.
node right here.
Yeah.
And then you can drag these other nodes over. So what kind of path do we want this to be?
Like,
Score mobility. Yeah, this would not be very good.
so you said bump side, right? Okay. So
It's a
with
reversal.
these, yep. So with these splines, you can turn the curvature of the path into more of like a natural sort of
It's on
movement.
reversal.
What?
It's on reversal.
Oh, okay. Yeah. There we go.
So you can change the arc of that the path is going to take as it
Yeah.
goes.
Like if you have one that's like too tight like this, it's gonna clip the charge station. But if you have one like this, it's gonna be fine. And well, what else? Like you guys want to pick up a game piece or something?
Yeah.
Yeah. Okay.
Sorry, what'd you say? Yeah, so then we can use events to pick up game pieces.
Mhm.
So if we come over here, sorry, if we go to, okay, it's already a stop point. Well, after we pick up this game piece, we would want to come back here to score it. And you can see if it's not an endpoint, we can select stop point, which makes it stop at that piece, or at that marker. And then if we come over to the event view, you can see the different stop points have markers on them. And if we select this, we can add events. So these event names can be whatever you want. We'll also show you how to add an event. So for this one, intake cube is what we have to pick up a cube on 990 or 9990 right now. And this will just make the arm go down and pick up the cube. Then if we go back to edit path,
Mhm.
we can come back to our last point.
Yep.
Make it go over the bump again. Oh, wow, we're going all the way
Oh
around.
yeah.
We're going to go score on the other side now.
Yeah. You can adjust these splines, make it easier movement.
Yeah.
Yeah.
So if we bring it over to a scoring points,
Yep.
sorry. Oh, why is it not dragging? There we go. If we drag it over to a scoring point,
Oh yeah. Extend the spline so it doesn't hit the charge
fix the spline
station.
so it doesn't hit that if it wants to. Yeah. We can come back to VS Code. And to add an event, first we'll want to go to robot container. There we go. And we'll want to add an auto command event here. Does anybody have any questions about that?
So event is actually just mapping to a command. So then it'll run that command or set of commands at that event.
So you can change the event name.
We used to have to make separate individual paths for each movement and then stop and go back and forth and do the event command. This just say run that path and set all the events in there. That's all.
So we're going to make a score high event. This is. And then,
Auto have its own command map then? So if you have different
It's
times.
global, so you can reuse the same event.
yeah.
Reuse the same event, but you'd have to set up mappings.
Mappings, so you set up all the events that you use in every one of your.
So you just set them up in the event map and then they get called based on the plan that you're running?
Yeah.
Okay.
Yeah.
Okay,
Path.
so it's a callback.
Yeah.
Okay.
Yeah, you can see we use a switch case so that every time it calls an event from Path Planner, it'll take the event name, and then it'll run whatever auto command is. So score high was our event. So we can have it, then you can fill this in with any command. So here we just have we have a utility to create our commands.
So will the event then run that command, and then once the command finishes, then it will continue the path onward?
Yeah.
That's as long
Mhm.
as if you don't
So-
have a stop event, an unstop event, or an end event, it'll run it in parallel as your path is still going. So it'll start those.
Yeah,
events
so
off.
we'll
Yeah.
also show how to make a marker which won't stop the path. That's really useful for an intake that still needs to be moving to pick up a piece. Because then it will. Because then it will keep moving as it puts down the arm or something.
What's there? Highlight there.
Sorry, there was just a top roller subsystem in there. Alright. Now it should fix itself. Yeah, that's good. And now, once we've added that case into the switch, it is fully ready to just add in the event into Path Planner.
It's been useful for us also if you wanted to just not affect the path, just take the event off it, not put command in there, and the path still runs without an exception saying no pointer or event doesn't exist. It just doesn't run the event. So you can always add your events that you want to do as you test individual ones. Put them in the command event map as you need. Is that?
More of a bottom up.
Yeah. We've done that when we haven't finished the arm or the arm's not been tuned yet. We don't want to be flying all over, so we just take our events out and then run the system paths.
So this event that we added right here to our stop point, it's a score high. So when we grab the cube or cone, we can score it on the high node.
Yeah. It'll just give it to our robot container, which will direct it to here with the event name score high. So it'll take this switch case and it will create a score high command that we run down here in the event map.
See if it just does a put just puts
Yeah.
it into event map, which is a main value pair, the string, and then the command.
And then once you're done with your path, once you feel that it's good, you can run it down here to check out the acceleration and stuff, which doesn't really help with how laggy it is right now, but
Yeah.
then we can exit out of Path Planner. Oh, we should name it first.
I do this stop first. Back to bed.
Does anyone have any names for this path that they want to name this?
Everyone wants to name the path? Alright. I will. So you can name it whatever you want. If you have a lot of paths, it's useful to have a nice naming scheme, but it will work regardless.
I should suggest not putting spaces in front of your names. We found out that's hard to see a problem because we've had that where you put a space in front of the name and you say, spell the same way, the case is right. You don't see that, it has a space in there, you don't see it. So never put a space in front of your filing or your. It's very hard to keep up.
So you can see we're putting this chooser here. We're sending this to Smart Dashboard. So we can just add the path option to the chooser. With whatever name we had. And then there's an optional pre-command. Sorry, wait. And then we'll add in the command that we assign around charge station. So we just make a command for the path. And for this,
We just do the.
you just
the
put
S
no.
word, copy that
Yeah.
from the previous one. You don't have to do the pre-command, you can do actually null. We added a pre-command to our path because we found out the first point can't be a stop. So when you score high, we do a pre-command, so you just have to score high command first, or do your scoring first, then append on what comes back to the path. Which is
Yeah.
and we found out you can't do movements in these paths or commands. You put a movement in there, path planner wants to know the movement.
Planner should be
So
capitalized.
you can't control your drivetrain
Thank you.
subsystem inside of a command. But you
There we
can
go.
control that. All the driving has to be done by your.
Should stop airing in a second. There we go. So now, if we rerun our simulation by pressing the screen arrow here, once it comes up in the option menu, we'll be able to select around the charge station the new path that we just created.
How many people have already used that now? Are using it? How would you know what all those?
I think it just crashed.
Yeah.
You're not gonna run that thing, are you?
Oh,
That path?
I didn't add the command here.
You see the 999 doing this path today?
It's not something I like to see, it's the action to see how well the planning was.
But yeah, this is how we make all of our paths. Does anybody have any questions from the entire presentation while we're waiting? No? No questions?
In yours, back in the simulation part, you talked about, you know, the arm in and stuff like that. How do you actually go do that? And I assume you have to do the same thing for some basic characteristics of the robot?
Yeah, so with the mechanism, we actually have a completely, oh wow, that's not gonna happen. We have a class for it. Let me see if I can find it quickly. But in this class, same thing with the Field 2D. In this class, it creates the arm, and for 930 we also had to create the manipulator and the elevator because they could move separately. And then you have to add the different ligaments. I highly recommend the docs because there's a lot of different things you can do with this. Each new mechanism, ligament 2D, needs a name, a length, an angle, a line width, and a color. And then you can append them to each other. So we had our arm appended to our elevator and our manipulator appended to the end of the arm. And it just allowed us to get those different values to get our full range of motion in. Same thing with the Field 2D. We have all of this in here, which basically just gives it the pose 2Ds of the robot. And for, you also said like the smaller things. The arm encoder. If I can find it quickly. Advantage scope allows you to log it pretty simply with just one line.
Yeah, that's more for getting current values to log in the stream. You're asking for simulation.
Oh,
It's
yeah.
just a mechanism that you have to find positions and lengths of where the ligaments in your arm are. You have other mechanisms too, we only use the arms and elevator.
Alright, let me restart this.
And is it a similar process for the drivetrain too, for doing the field?
The poses?
Yeah.
The pose is actually much easier. You just have to deal with your ergonometry pose 2D and keep on mapping it to a field 2D object. And it takes care of everything else for your CI. The Vantage Scope, right? Is somebody else doing a Vantage Scope today? More of a Vantage Scope?
Matt's doing debugging with it.
So we're going to talk also about, you can also see every individual module, what it's doing, and things like that. I'm not sure if he's going to go into that in detail, but the Vantage Scope has a lot more details where you can see it here. Especially a swerve drive, where you see it. Tank is much easier. But swerve drive is still all over the place.
Yeah, so we're just gonna wait for this. I can go back to the slides quickly, but pretty much that's it. If you have any more questions at some other time.
You got 10 minutes, yeah?
Yeah. I thought it ended at 9:50. Yeah. Does anybody want us to recap anything quickly? No.
The feedback URL went around. Just scan it and fill it out later today or whenever you have a chance.
Yeah, thank you all for coming. Here's a bunch of our team socials. If you have any more questions, you can reach out to us. We have people standing at the door. Yeah, that's everything. Feedback, there was a QR code, yeah, it's being passed around.